What makes a balloon float? While a submarine can move freely underwater, is there anything to support them to keep floating? Apparently, an upward force is needed to balance the downward gravity, which is buoyancy. Back 2,000 years ago, there was a famous scientist called Archimedes. One day, a king wanted to check his crown was made of gold or not. Then he requested Archimedes to find a way to examine it without breaking. It was an extremely hard mission for him, and it took him a lot of time to think. Someday, when he was taking a bath, he suddenly realized that the water would pour out when he entered the bathtub. The volume of himself should be equal to the volume of pouring water. So he ran as soon as possible and told the king about his idea. He put the crown and the gold, which had the same weight, into 2 containers filled with water, and checked the volume of pouring water separately. According to Archimedes' idea, the volume should be the same. However, they were not. By using this method, he helped the king figure out that the crown was not totally made by gold. Someone may get confused that why he can figure out the relationship between the volume and density. So let me just explain it a little bit. Gravity should be equal to buoyancy. So buoyant force is equal to gravity. And this is the basic idea of Archimedes' principle, which explains the buoyant force on an object is equal to the weight of the fluid displaced by the object. To find the relationship between the volume and density, we can use the equation mass is equal to density times volume. Then we can get buoyant force is equal to rho times V times G. In the story, 2 objects have same mass, so rho times V should be same as well. However, the changes of volume were different. That means the density was different. Apply buoyancy to our daily life. Submarine can be a good example. A submarine can float because the weight of water that is displaced is equal to the weight of the fluid. This displacement of water creates an upward buoyant force and acts opposite to gravity, which would pull the ship down. When a submarine suspends under the water, buoyancy is equal to the weight of itself, and buoyancy of the submarine will not change when it totally sinks. If a submarine needs to go deeper, to inject some water into main ballast tank could change its weight. If a submarine needs to float, just draining some water out of the tank, the volume of the fluid decreases and its weight would decline. So buoyant force decreases as well. In addition, we did an experiment to prove this idea. We drew 2 holes on the bottle on different sides. Then we start to blow through a straw. Meanwhile, some water keeps coming into the bottle, and the bottle goes down. On the other hand, when we aspirate, water will go out of the bottle. As a result, the weight of the bottle decreases and it will float again.